Good afternoon. My name is Sean. I come from Taiwan office data team. Today, I would like to share my experience about using BERT to improve the keyword-based search. This is my agenda. I will start from our search function in our inline service. As we know, search function is everywhere. We can see search in each line service, and it helps us to find what we want. No matter what is service or product or information, it will help us to find what we want quickly. And how do we evaluate the search result? I think search is kind of different from recommendation. Search is a ranking problem. The ordering is more important than the single instance prediction. And the main goal we want to solve is to reduce the semantic gap between user query and the documents. The document means the information, the text document, the product, and every single instance. There are two key points in this problem: features, especially semantic features, and ranking function. In this work, I use Elasticsearch as a search backend, and by default, Elasticsearch uses TF-IDF base to calculate the scoring. But in traditional TF-IDF, it's keyword based, so its limitation is like these two examples. First one, if there is no shared keywords, the document is not easy to be found. And the second one, even there is shared keyword, but what if you use different description word to describe the same thing? It's also difficult to find the result. So I want to use embedding to solve this difficulty. As we know, word embedding achieved lots of difficult NLP problems in recent years, and we can use embedding to reduce the very, very long vector representation into short and fixed length to a low dimensional space. And in maybe 2 years ago, Google he proposed a new BERT, a new NLP model, BERT, and he used a huge corpus to train the vector space. And in this work, I use BERT as a pre-trained language model to discover the semantic words, to discover implicitly semantic behind each keywords. What I did is my pre-process is to use the BERT to do sentence encoding, and then use the nearest neighbor to do index. So in this manner, I can use the same way to do sentence encoding for the online query, and to do the nearest neighbor search in the document index. And as we know, the traditional information system, we can use a man-made scoring function to find. We can tune the man-made scoring function to find a best evaluation function to do the search, to do the rank. But as the search engine grows, there are more and more features we want to consider. In today, maybe more than hundreds. It's not critical to use the man-made approach to find the most appropriate scoring function. So many people have an idea. Why don't we use machine learning to find the best function for us? So we try to introduce the learning to rank concept to achieve this. And what is learning to rank? It's applying machine learning to construct ranking models for information retrieval systems. So we care more about ranking rather than the rating prediction. How do I achieve it? This is the search architecture. So every query, we will use the filter to find the potential matches and the score by each different semantic models, and assemble the model results to produce the final ranked results. Not only BERT, we can consider more semantic features to contribute to a scoring function. Except BERT, we may consider an ER, we may consider DSSM, and more semantic features. And this is a very basic example in Elasticsearch custom scoring function. As we can see, we can use this weighting parameter to tuning the weighting for each documents. This is a very basic example, so only consider one parameter from BERT, but we can assemble more ranking model here. In the traditional search workflow, the whole search workflow may look like this. We collect the data and preprocess and build the inverted index. And we can use the inverted index to serve the online query. But in the new learning to rank method, we need one more step. We need to select the useful semantic features and training the ranking models and rewrite the scoring function and use some metrics to find the best one, maybe NDCG precision at top K and MAP, and then we can use it to serve the online query. But this is a very basic idea. I think there are still many considerations we need to approve. In the training, we need a good judge list to match user needs and the search quality, and we have to define a good metrics to measure in the search results good enough or not. And how to incorporate with the embeddings into the scoring function is also a problem. And since we may need to retrain the embedding model many times. So how to synchronize the version between the indexing and the serving layer is also a problem. And finally, we may need a good approach to adopt the A/B testing to make sure the search result is match our expectation. This is my slide. Thank you.